In this lecture, I will explain about next hop self feature. Let's assume we have three routers. This router belongs to ISP and R1 and R2 router is in same AS 65000 and they will make IBGP. And with ISP router, R1 will make EBGP peering. Let's assume R1 router receive an update from ISP. In that update, there is one prefix 8.8.8.8 with next hop address 10.10.10.1. So R1 received that update from EBGP router and that same update will send to IBGP peer, that is R1 router, without changing the next hop IP address. So router 2 will have the route for 8.8.8.8, but R2 router will not able to communicate with ISP router. Why? Because the next hop IP address router 2 receives 10.10.10.1. Router 2 will not know about the 10.10.10.1 network. Actual R2 next hop is this one, 192.168.1.1. So R2 router will not able to send package to that network due to there is no route available in the routing table. So to make 8.8.8 network reachable from R2, there are two ways. First, advertise that next hop via any IGP protocol, or you can use next hop self command at R2 router, rather R1 router. With that command, what it does, when R1 send that prefix 8.8.8, it will add that next hop, change that, actually it will change the next hop 10.10.10.1 to 192.168.1.1. Then router 2 receive that update and router 2 will know about next hop IP address 192.168.1.1. Then router 2 will be able to communicate with 8.8.8 network, that is ISP router. So let's go into the lab. I will show you the practical. Let's change the router name as well. This is the ISP router. Configure the physical interface and loopback interface as well. Set interface G0/0/0. Family inet address 10.10.10.1/30. Set interface loopback family inet address 8.8.8.8. Set routing option autonomous number, in our case 1000. Now configure BGP, edit protocol BGP group, give any name EBGP, set local address 10.10.10.1, set local AS 1000, set neighbor 10.10.10.2, set peer AS 65000, set log-updown top. I will create one policy and I will advertise that 8.8.8 network to R1 router. Set policy option policy statement, give any name EBGP export term1 from route filter 8.8.8/32 accept term1, then accept term2, then reject. Now apply that policy against that neighbor. Edit protocol BGP group EBGP set export EBGP, commit and quit. Next, configure the same on R1 as well. Let's change the host name. System host name. This is the R1 router. Now configure the physical interface and logical interface as well. Set interface G0/0/0.0 family inet address 10.10.10.2/30. Set interface loopback family inet address, in this case 1.1.1. Then configure the AS number. Set routing option autonomous system 65000. Now configure BGP EBGP now configure EBGP session. Edit protocol BGP group EBGP. Set local address 10.10.10.2. Set local AS 65000. Set neighbor 10.10.10.1. Set log-updown. Set peer AS 1000. Set policy option policy statement EBGP export term1 from protocol BGP direct as well. Then accept term2, then reject. Edit protocol BGP group EBGP set export EBGP, commit and quit. Now let's see whether BGP session has been established or not. Show BGP summary. Yeah, BGP session has been established. We will check the receive and advertise route. Show route receive protocol BGP 10.10.10.2. So we are receiving 3 routes from the neighbor, and let's check the advertise route. Show route advertise BGP 10.10.10.2. So we are advertising 8.8.8 prefix. So let's check on R1 router. Show route receive protocol BGP 10.10.10.1. Perfect. We are receiving 8.8. prefix. Let's check the reachability 8.8.8. We are able to pick. Now configure the IBGP between R1 and R2 router. Configure it. Edit protocol BGP group IBGP. Set type internal. Set log-updown. Set local address 192.168.1.1. Set local AS 65000. Set neighbor 192.168.1.2. Set peer AS 65000. show. Okay, I'll create one policy as well. Set policy option, policy statement, give any name, IBGP, export term 1 from protocol BGP, then accept term 2, then reject. So we have not configured the IP address which is connecting to R2 router. So let's configure. Set interface G0/0/1.0 family inet address 192.168.1.1/30. Show compare, commit and quit. Okay, let's configure the BGP on router 2 as well. First configure the physical interface. Set interface G-0/0/ what was that, 1 in our case. Family inet address 192.168.1.2/30. Set interface loopback family inet address 2.2.2.2. Now configure BGP, edit protocol BGP group IBGP. Set local address 192.168.1.2. Set local AS 65000. Set peer AS 65000. Set neighbor 192.168.1.1. Set log-updown, show local address, neighbor. Okay, perfect. Top. Let's configure the autonomous system number 65000. Perfect. Commit and quit. Let's see whether BGP has been established or not with R1 router. Show BGP summary. Now it is established. Let's see what are the routes we are receiving from R1. Show route receive protocol BGP 192.168.1.1. So we are not receiving any route, but if we see show BGP neighbor 192.168.1.1, here you can see we are receiving one prefix and accepted one prefix. But when I am checking the receive route, there is no update. Why? Actually the route is coming in hidden. See, 8.8.8 prefix is coming in hidden. The reason behind that, when next hop is unreachable, then routes will become in hidden. So see, what is the next hop? 10.10.10.1. But as per our topology, what will be the next hop for R2? 192.168.1.1. Actually router 1 received the same route. Show route receive protocol BGP 10.10.10.1. that same route, router 1 receive 8.8.8 with next hop 10.10.10.1 from ISP router. Same update router 1 sends to router 2. There is no change in the next hop. By default, IBGP will not change the next hop when sending the update which they are received from EBGP router. So in this case, router 2 will not able to ping. let's try 8.8.8. See, there is no route for the host. So in this case, if you want to reach 8.8.8 from router 2, we have two options. First, we can advertise that next hop IP address via any IGP protocol, or else we can use next hop self command at R1. Let's see. I will go to the R1 and I will say next hop self in export policy against R2 router. What is the export policy? Show configuration policy option policy statement. So this is the policy we have created. So I will make some changes. So policy option, policy statement, term 1, then next hop self. This is the command. Show compare, commit and quit. So now next hop should be changed. Let's see. Show route receive protocol. Show configuration, policy option, policy statement, IBGP export. Actually, this is the policy which is going towards IBGP. Previously, we have done the changes on the EBGP policy. So I have done the change. I will revert the change. The correct policy is this one, IBGP. Now next hop should be changed. Maybe it will take some time to refresh. Let's see again. See, there is no hidden route. See, now the next hop is changed. Previously next hop was 10.10.10.1. Now after making the changes, now next hop is 192.168.1.1. Now R2 router should be able to reach ISP router. Let's see, ping 8.8.8.8. See, now we are able to reach 8.8.8. That's it in this lecture, guys.